An array is a collection of data items of the same type stored in contiguous memory locations. In C++, arrays can be used to store a fixed size sequence of elements. Here is the syntax for declaring an array. Type is the type of elements the array will hold. Array name is the name of the array. An array size is the number of elements in the array. For example, here is how to declare an array of integers with 5 elements. You can also initialize an array at the time of declaration. Here is an example. This initializes an array of integers with 5 elements, where the first element is 1, the second one is 2, and so on. You can access the elements of an array using the index operator, the brackets. The index starts at 0 and it goes up to array size -1. Here is an example. The code here declares an integer array named numbers with 5 elements and initialize them with the value 1, 2, 3, 4, 5, and 5. These elements of an array can be accessed using their index, which starts at 0 and goes up to array size -1. In the first cout statement, numbers 0 refers to the first element of the array, which is 1, so the output is 1. In the second cout statement, number 3 refers to the fourth element of the array, which is 4, so the output is 4. You can also modify the elements of an array using the index operator. Here's an example. This code declares an integer array named numbers with 5 elements and initialize them with the value 1, 2, 3, 4, 5. The line here assigns the value 10 to the third element of the array. Remember, the array index starts from 0, so the first element has an index of 0, the second element has an index of 1, and so on. Therefore, number bracket 2 refers to the third element in the array, which has the initial value of 3, and then it is updated to 10. Finally, the line cout this numbers bracket 2 outputs the third element of the array, which was modified in the previous line to a value of 10. Therefore, the output is 10. Arrays can also be used in loops for easy traversal of all elements. Here's the example of a for loop that prints out all the elements of an array. The for loop is used to iterate through each element of the numbers array. The loop initializes the variable I to 0, which is the index of the first element in the array, and then increments I by 1 on each iteration of the loop until I is equal to 5. The loop condition I less than 5 ensures that the loop only executes while I is less than 5, which is the number of elements in the array. The statement outputs the value of each element in the array separated by a space. During the first iteration of the loop, I equals 0. So number bracket I refers to the first element in the array, which has a value of 1. The cout statement outputs the value of this element followed by a space. On the second iteration of the loop, I is 1, so numbers I refers to the second element in the array, which has a value of 2. The cout statement outputs the value of this element followed by a space, and so on, until the loop has iterated through all of the elements in the array. The output of the program is 1, 2, 3, 4, 5, which represents the values of each element in the numbers array separated by a space. You can pass an array as an argument to a function. This allows you to manipulate or operate on the elements of the array inside the function. To pass an array as an argument to a function, you need to declare the function with a parameter that is an array of the appropriate type. The array parameter must also specify the size of the array, which can be done using either a constant value or a constant expression. Here is an example function that takes an array of integers as an argument and finds the sum of all elements in the array. The function SumArray takes 2 arguments, an array ARR of integers and an integer size that specifies the size of the array. The function then calculates the sum of all of the elements in the array using a for loop and outputs the result. Here is an example of how to call the SumArray function with an array of integers. In this example, an array of integers named numbers is declared and initialized with the value 1, 2, 3, 4, and 5. The variable size is also initialized with the value 5, which is the size of the array. The SumArray function is then called with the numbers array and the size as arguments. When the SumArray function is executed, it calculates the sum of the elements in the numbers array and outputs the results as sum of array elements is 15. In C++, when you pass an array to a function, the array is actually passed by reference. This means that the function receives a reference to the original array rather than a copy of the array. When an array is passed by reference, any changes made to the array inside the function will affect the original array in the calling code. This is because the function is working directly with the memory location of the original array. Here's an example function that takes an array of integers as an argument and modifies one of its elements. In this function, the array ARR is passed by reference using its name. The function modifies the first element of the array by setting its value to 10. Here is an example of how to call the modify array function with an array of integers. So in this example, we declare an initialized numbers array. The modify array function is then called with the numbers array as an argument. The function modifies the first element of the numbers array to 10 when the modify array function returns. The value of the first element of the numbers array has been changed to 10. This is because the modify array function modifies the original array in memory rather than creating a copy of the array. So when modify array function returns to the main function, the cout numbers bracket 0 will output 10. In C++, arrays are passed by reference when they are used as function arguments. You can use type def keyword to create a new type name for an array. This can be useful for creating more descriptive type names or for simplifying complex type names. Here's an example of how to use type def to create a new type name for an array of integers. In this example, we used type def keyword to create a new type name, integer array, int array, for an array of integers with a size of 5. This allows us to use int array as shorthand for the full type name int bracket 5. Now we can declare variables of type int array instead of using the full type name. So in this example, we declare a variable numbers of type int array and initialize it with the value 1 to 5. Using type def for arrays can make the code more readable and easier to understand, especially when dealing with complex types or large arrays. A two-dimensional array is a collection of elements arranged in a rectangular grid. It can be thought of as an array of arrays, where each subarray represents a row of the grid. Here's the syntax for declaring of two-dimensional array, where type is the type of elements in the array will hold. Array name is the name of the array. Row size is the number of rows in the array. And a COL size is the number of columns in the array. For example, here's how to declare a two-dimensional array of integers with 3 rows and 4 columns. You can initialize a two-dimensional array at the time of declaration by enclosing the elements in curly braces and separating the rows with commas. For example, this initializes a 3 times 4 array of integers with the value 1 through 12. There are 3 rows and 4 columns. You can access the elements of a two-dimensional array using 2 indexes. The first index is the row index, and the second one is the column index. Here is an example. We output the first element, which is in index row 0 and a column index 0. The second element is row index 1 and a column index 2. You can also modify the elements of a two-dimensional array using the row and the column indexes. Here is an example. This modifies the element at row 1 and column 2 to have a value of 20, and then outputs the new value. You can also use nested loops to iterate through all the elements of a two-dimensional array. Here's an example of a nested for loop that prints out all the elements of 3 times 4 array. This code declares and initializes a 2D array named matrix with 3 rows and 4 columns. The elements of the array are initialized with values in the brace enclosed list. The nested for loop is used to iterate through the elements of the matrix array. The outer loop iterates through each row of the array, and the inner loop iterates through each column of the current row. On each iteration of the inner loop, the cout statement print out the value of the current element of the matrix array, followed by a space. After the inner loop has printed out all the elements in the current row, the cout statement here is executed to move to the next line. Overall, this code prints out all the elements of the matrix array in a row major order, separated by spaces and new lines. The output looks like this. A string can be treated as an array of characters, just like a char array. This means that you can access and manipulate individual characters in a string using array index notation. Here is an example of how to declare and initialize a string. In this example, we declare a string variable named greeting and initialize it with the value hello world. You can also modify individual characters in the string using the same array index operator. In this example, we modified the first character of the greeting string by setting it to the character J. We then output the modified string to the console. You can also use loops to iterate through the characters in a string, just like you would with a char array. Here's an example of a loop that prints out each character in the string. In this example, we use a for loop to iterate through each character in the greeting string. The length method is used to determine the length of the string or the size of the string. The loop then prints out each character in the string, separated by spaces. Let's do an exercise after Chapter 7, the programming challenge number 1, finding the largest, smallest array values. So the question asks us to write a program that lets the user enter 10 values into an array. The program should display the largest and the smallest values stored in the array. So for this program, we have the following subtask. The first thing is we declare variable, right? We declare the variable for the array. Second, we get an input of the array, so we should have a loop to ask the user to enter the value for each element in the array. Then we find the largest and smallest value in the array. Then we display the result. We start from an empty program, so let's write some comments. Chapter 7, largest, smallest values in the array. Then hashtag include IOStream. Do we need some formatting here? If we need, we come back later. So using namespace std integer main. So the first task is we define variables. The array size is 10, so we usually have a constant. So we put const keyword, constant integer size, all capital, let's say 10. So we declare a constant variable size equal to 10. That's the array size. Then the array name, we say it's values, and the array is an integer value. So int, that's the array type, values, that's the array name, then brackets, the square brackets contain the size of the array. So we declare the size, the variable is size in capital. So this is an empty array. Each element is integer type and holds for 10 elements. Next one, we can declare a counter. The counter is for the loop. So integer count. Then integer largest holds the largest value. Integer smallest holds the smallest value. Then we're going to output a message. Cout. The program will ask you to enter 10 values. Then it will determine the largest and the smallest values you entered. Then we are going to do a loop, right? Because as 10 elements, we don't want to, manually write anything for each element. We can use a loop to do it automatically. So we can use a for loop here for count equal 0, count less than size, count plus plus. Inside the for, we first output a message. Please enter an integer value, semicolon. Then we're seeing, so you're seeing, you provide a variable name. Because we're seeing for each element in the array, so we say value, bracket, square bracket, and then we put count. So value, bracket, count, that stands for the element. So it should be values. Okay. So need to be exact variable names. So in the for loop, we get input for each element in the array. Then the next step is to find the largest and the smallest values. So we are going to initialize some value for largest or smallest. Otherwise, they contain the trash value. Shall we initialize to 0? Or smallest, we say equal 0. Are those good? No, because the array can contain negative values, right? If all the values in the array contain negative values, what is the largest equal 1 or equal 0 or smallest equal 0 mean? So we need to actually should assign the first element of the array to the largest. So we say values, bracket, 0. So we assign the largest to values, the first element of the values. Same thing for the smallest. Then we write a loop. We start to loop through each element to compare to largest and smallest. So for count equal 1, so we start from the second element, which is the count, right? The value, that's the array. Then bracket 1, that's the second element. So count equal 1, count less than size in capital case, count plus plus. Here we compare, we have a if statement. If the current element is greater than largest, then we swap and we assign the current element to largest. Then we do the same thing for the smallest. If the current element is less than smallest, so we swap their values. So smallest equal values count. So in this way, we are going to find the largest and the smallest in the array elements. So next task is to display the result. So we just have an output a message, cout the largest value entered is largest ENDL. Cout the smallest value entered is smallest ENDL. Return 0. Now we finish our program. Let's compile and run. So let's enter some random number. The largest one is 80. The smallest one is 1. Okay. So let's make the display message more clear so we know which element we are entering. So we say please enter an integer value for array element. Then we put the number, which is a counter count. Okay, so we know which element we're entering. Let's run again. Two, three. So the count from index 0 to index 9, right? That's array because in C++ arrays start from 0. So here we can see count plus 1. Now it says element 1, okay? $34 is the largest and the 1 is the smallest. Okay. We can also use vector for this array. So instead of integer arrays size, we can say vector. Then here we give the type of the vector. So the vector will contain integer type, and we give the vector names. and provide the size. Right now, the compiler didn't recognize what is vector, so we need to include the STL vector. So once we include the vector, the compiler know what is vector the keyword is. Let's compile. We saw a lot of errors here. We didn't add much code, so let's see vector integer values size. Okay, for the integer values size, it's the size is enclosed in the square brackets. Well, for the vector, the size should be enclosed in round parentheses. Okay, let's compile. Now we don't have any error, so let's run it. The answer looks right. Yeah, the biggest one is the 67, the smallest one is 0. So pay attention to the syntax here. The size in the vector is optional. We don't have to declare the number of elements that the vector will have. Because here we say 10 elements, that's why we put the 10 for the size. But for the vector, it can dynamically increase and reduce the size of the array. And the vector can report the number of elements they contain, like we use the method .size. So the static array is static, like integer values size, that's a static array. Vector is a dynamic array. Here, if we change to values.size, so values.size will return the size of the vector. So let's run it. So it also works, we can see. So this biggest one is 88, smallest one is 2. We can see conventional array is a fixed size sequential collection of elements, and they are more memory efficient. So if you know the size of the array, you can use a static array. And the vector is dynamic, so it can increase with the insertion of elements. Vector take more time in accessing elements. Vector is not that memory efficient as a conventional array, but vector has more functions and is more flexible.